Hello guys, welcome to my YouTube channel Chem Discussion. Myself Tapas, I am your online educator. Today I am going to discuss aziridination reaction. So what is aziridination reaction? To form aziridine ring in a substrate. So let's see how aziridine ring looks like. As we know that this is the epoxide ring. Now it's analogous another three-membered ring, or you can say three-membered cyclic ring is the aziridine ring. And in this video I will be discussing about how to form aziridine ring in a substrate. By two ways we can synthesize aziridine ring in a substrate. One is a stepwise process and another one is direct process. So by this two method we can easily synthesize this nitrogen containing three-membered heterocycle, that is aziridine. Now let's talk about the aziridination. First, stepwise process. In the stepwise process, from olefin, first we need to have the epoxide, that is, then epoxide ring is opened up by azide anion to form a azide intermediate. This is the azide intermediate. Now this azide intermediate gives the aziridine ring. This is our aziridine ring. So by this way we can synthesize aziridine ring. So how can we form the epoxide from olefin? By using hydrogen peroxide or different acid like metachloroperbenzoic acid, we can form epoxide. Now what is the source of azide here? We can use sodium azide in acetonitrile solvent. It is a good source of azide to form this azide intermediate. Now this cyclization process can be facilitated by using triphenyl phosphine. By using triphenyl phosphine we can have a easy cyclization process to form this aziridine ring. So this is the stepwise process by which we can form aziridine ring. Now I will discuss about the direct aziridination process. The direct process. For the direct process we can use the nitrine or nitrinoid. What is nitrine? Nitrine is a nitrogen source. It looks like this, and here this portion is actually inserted into the olefin to give aziridine, and this is called nitrine. Now What is nitrinoid? Nitrinoid is nitrine is coordinated with a transition metal. So if nitrine is coordinated with transition metal, this gives nitrinoid. Nitrinoid. By nitrinoid technique, we can easily synthesize aziridine ring by direct aziridination technique. Here, two different reagent is used. One is very much this, and this is called N-tosyl phenyliodinane. By using N-tosyl phenyliodinane, we can have aziridine ring, and here generally different transition metal is used, and among them copper 2 is the best. So let's take an example. Suppose styrene is our olefin source and N-tosyl phenyliodinane and copper triplet. This will give the N-tosyl aziridine ring. And here, this is the source of nitrine. It is coordinated with the transition metal copper to give nitrinoid. And this nitrinoid is inserted to the olefin to give aziridine. Now, we will see another good reagent to form aziridine, that is N-chloramine or N-bromamine. Let's see the structure. The structure of this is the methyl group. The structure of N-bromamine or N-chloramine is like this. Here, in case of chloramine, the chlorine will present. In case of bromamine, the bromine will present. This is the structure of N-chloramine or N-bromamine T. Now, using this, we can easily synthesize the aziridine ring. Here, one more thing is used, like this is the as a source of bromine. We will see the role of this tertiary ammonium bromide in the formation of aziridine ring. Let's see the mechanism. Let's take an olefin. This is our olefin. Now, this tertiary ammonium salt will produce bromine in the reaction mixture that forms bromonium ion with olefin. Now, the N-tosyl chloramine, or you can say chloramine T, behaves as a nucleophile to open up this bromonium ring to form a intermediate. Now another molecule of chloramine T will take this chloride, and this bond will shift to the nitrogen. The nitrogen will get anionic charge, and this anionic charge will attack this to this carbon, and then bromine will go out as a good leaving group to form the N-tosyl aziridine ring. So by that way, by chloramine T or bromamine T, we can synthesize aziridine ring. Now I will discuss asymmetric aziridination, just to give you an example. Let's take an example. Suppose this is our olefin source. Here we use the N-tosyl amino phenyl iodine, and copper triplet is used, and as well as we use a chiral ligand, that is the bis oxazoline ligand. By presence of this bis oxazoline ligand, we can have asymmetric aziridination on this substrate. So this is a very beautiful example, and that's it for today. Thank you.